probably how you do it as well. But if you were just doing, say, a block in a CMS, you probably only include this div here, the container. Oh, sorry. The container and the JavaScript. You wouldn't need the rest of it because it's already within a web page. So what this actually does, the head of the document is including 2 JavaScript files. Here I've included one called prototype. This is a JavaScript framework which handles a lot of the common tasks which we want to do but aren't already built into JavaScript. So it's basically just like a big library of functions that's available to us. And we'll see in the lab this will allow us to do things like Ajax and processing our data and sorting it really easily without having to write our own sorting functions. And lib.js is just going to be our own library of functions which are going to be used for the widget itself. And then, as I say, the container is where it's all output. We don't need anything else on here at the moment because everything else is going to be presented to us by the widget. If you wanted to have an interface for user input, you could also display that here using an HTML form. But for our purposes today, we're just going to be outputting some data. So we don't need that at the moment. So we're going to go through the 3 stages which we need with all programs. We need some input of some sort. That could be from the user, that could be data from somewhere else. We need to process it so that it gets into a form which is useful for us, and then we need to output it so that the user can see the results. So yeah, as I've discussed, there's various data sources we could use. We could, in fact, use a database if we, in a situation where we're running on a web server which has something like a database server on there. If we've got the data we want in the database, we can use an Ajax call to extract the data from the database and display it in our widget. So for instance, if you were running on a content management system and you wanted to get out, say, all of the users who are online at the moment, you could pick that up from the database. Web services, as I've discussed, you can get web services that will give you all sorts of information. It could be weather, it could be the latest photos that are uploaded to Flickr. The one we're going to be using at the moment looks at album sales. So we're going to be getting data for the top 10 album sales. User input, as I say, if you say you want to do a calculator, you can just have them put in the numbers and the calculation they want to do. You could have them put in some text. It could send it to a spell checking web service and give it back to them. Other sensory input, you could have a GPS. So if you wanted a widget that gave them directions, you could get data from the GPS if they had one on their phone or attached to their computer. If you wanted to upload a photo to Flickr, you could have them take it with their camera. The widget could then take the photo from their camera. And if you wanted to monitor network traffic, you could write a script which watched your network interfaces and saw what data was going through them and reported that to the widget. So there's lots of different places we can get data sources from. But what's quite important to notice is that none of these are actually stored within the widget. Because of the nature of the widget, it's generally a very small, lightweight program which only does processing and display. It never has the data stored within it, usually because it's network enabled, which means that we have all of these things available to us. So a bit about calling a web service, because this is how we're going to be getting the data for our widget in the lab. Ajax stands for Asynchronous JavaScript and XML. It was only really called that to give it a nice acronym which you could say easily. It doesn't have to be XML that you use, that's just a commonly used data format for it. As I said, it is asynchronous, which means that it makes a request without having to reload the page as a whole, and remains interactive. That means it gives you, like you were using a desktop application, you don't have, when you're using an application on your desktop, every time you click, the whole interface doesn't have to refresh, and that's what Ajax is trying to achieve.
Can we show them an example of an Ajax thing on a web page? I think anywhere. Yeah. I think. So.
I'll just show you a nice easy one. So if I type something into Google, say Right, you can see here it's given us a load of results just straight away without having to reload the page. So what it's done here is every time I press a key, it goes away, does a Google query, gets a list of results and puts them in the page without having to reload. So it means that I don't have to click Google search every time I want to see what results I might get. So that's just an example of the kind of things Ajax can do.
Thank you.
Right, and one important thing to know about Ajax is that web browsers use a security feature called the cross-domain policy. What that means is that, say I'm running a widget that's served from example.com, I then can't request some data from example.net because it's on a different web server. Now you can get around this in a number of ways. One of which requires a proxy script, which is the first example we're going to look at in the lab, where you have a server-side script running on your web server, and your Ajax call goes to that proxy script, which then goes to the web service on another server, because that's allowed. The reason for this is to stop basically malicious scripts being able to insert stuff into your page from another website. A vulnerability called cross-site scripting, which you might have heard of. Because that can allow them to say, they might then put a link in your page which looks like it's part of your site, but actually then goes to a form on another site which asks them to put in their credit card details, and they think that it's a site they trust because they think it's you. As I said, the XML bit of JavaScript isn't necessarily what it returns, but it returns some sort of data. It could be XML, it could be some other formats which we're going to talk about in a minute. So I'm sure most of you have probably seen XML at some point, one way or another, but here's just an example of what it might look like. You'd have a root tag, which they're all the tags in XML are generally semantic tags, so they'll tell you what their contents is about. So the opening tag in our case is called albums, because inside it is a list of albums. Inside there, there's then a series of album tags, and inside each album tag there's a series of tags with the title, artist, label, number of sales, year it was released, things like that. So what we've basically got here is a load of sort of objects, just codified in a way which we can process them quite easily, and we can also transfer them, and the added bonus is that it's human readable. It's not just a binary string which our computer then has to translate for us. If we want to look at the XML and see what data it is, we can understand it quite easily. Another method we can use is called JSON, or JavaScript Object Notation. You'll see in the lab, this is actually, as well as being a data transfer format, it's also a way of programming in JavaScript, a way of defining things in JavaScript. Now, it looks quite sparse, but this gives us an advantage that it doesn't require a lot of bandwidth to transfer. And once you understand it, it's quite simple. In fact, I think you've got that on the next slide. No. In fact, yeah, I'll get onto that in a minute. Once you understand syntax, that's just showing you what it looks like. So here we've got some objects with some properties, and we'd have a list all the way down. These square brackets show that there's an array of objects, but I'll come to that in a second. So when we're looking at whether we want to use XML or JSON for transferring data, a few of the arguments for and against each. JSON, as you saw, is a lot less verbose. You don't have to have an opening tag and a closing tag for everything. You just label each attribute once, and then you just have an end of the line, and then the next one's there, which means obviously you don't then have to transfer 2 tags for each. So if you've got a lot of data, that can save you a lot of bandwidth and make everything a lot faster. Probably the real selling point on JSON is that because it's native JavaScript notation, you don't then have to write a function to parse it and get all the data out, because it is the data. You can just say variable equals a string of JSON, and then that becomes an object or an array or whatever it is that's defined in that data block. Whereas with XML, you have to write a parser which goes through, finds each opening tag, stores the data inside the opening tag, finds the closing tag, and that gets quite memory intensive and takes quite a long